Okay, let's do a problem from chapter 12. Two positive charges, each of magnitude 4 times 10 to the negative 6, are located a distance of 10 centimeters from each other. Let me fix something real quick. This should be coulombs. What is the magnitude of the force exerted on each charge? So we're looking for the force there. And here on B, on a drawing, indicate the directions of the forces acting on each charge. Okay, well let's, we can draw it out first. We can answer B first. Let's do that. So here we got something that both charges are hanging from. Set them next to each other here. This one's positive. This one's positive. They're both that many coulombs of positive charge. Well, get two positive charges together, they are going to repel. So they're going to have forces pushing them away from each other. Okay, we can find the magnitude of that force by using this equation. The force equals K, which is a constant, times Q1 times Q2, all divided by R squared. R is this distance that the charges are away from each other, so that's R. Q1 is, let's write out our knowns and unknowns now. It's black. Q1 is 4 times 10 to the negative 6 coulombs. Q2 is 4 times 10 to the negative 6 coulombs. Our R is 10 centimeters. We don't want to be in centimeters. We want to be in meters. So just take 10 divided by 100 and you get 0.10 meters. And what else? Oh, we have K. Okay, if you look it up in your book, what is the book's value? Okay, 9.0 times 10 to the 9th Newton meter over Coulomb squared. Okay, so we're looking for the force. That's our unknown. We have K, we have Q1, Q2, R. Hey, we're good to go. All you got to do is plug into the equation. And let me do it with just the units. So looking at just the units, you have K's unit, which is Newton meter over Coulomb squared, times Q1 would be a Coulomb, Q2 would be a Coulomb, all over R, which is a meter R squared, so that's a meter squared. And so Coulomb cancels out with Coulomb and Coulomb. Then you have meter squared over, oh, this needs to be a meter squared. So you got Newton times meter squared over meter squared. Those two cancel, and you're left with a Newton. That's what you want force measured in. You want it in newtons. Alright, so we know our answer is in newtons. To plug in the numbers, you'd have 4 times 10 to the negative 6. If you're using a calculator, make sure, well, I hope you are, make sure you use parentheses on these. You don't always have to, but sometimes it can really help with your calculators helps them not get confused. And then 0.10, that's squared, and get 9.0 times 10 to the 9th. So you're going to multiply all the numbers along the top, divide by 0.1 twice, you can do that, or multiply along the top, hit equals, do 0.1 squared, hit equals, and then hopefully wrote down the top number, divide by the bottom. Again, if you have problems with your calculator, let me know and I can help you with that. But there's your force. Make sure it's in newtons. Alright, you can